Hello guys, welcome once more to another video in this YouTube channel. So in this video we are going to be looking at this question which came in the Littoral mock of mathematics paper 2 for this year. So the question reads, given that p of x is a polynomial of degree 3 and that p of x leaves a remainder of 12 and negative 8 when divided by x minus 2 and x plus 3 respectively. A. Find the remainder when p of x is divided by x squared plus x minus 6. Given also that x minus 1 is a factor of p of x and p of 0 is equal to negative 2, find the quotient when p of x is divided by x squared plus x minus 6. Express p of x in the form ax squared plus ax cubed plus bx squared plus cx plus d, where a, b, c and d are constants. So this particular question requires the students to actually understand the principle behind the factor and the remainder theorem. So I'm going to do a little bit of demonstrations here and we see. Now the first thing to note is that if I have two polynomials, right, so consider two polynomials, let's call them f and g. Okay, now if I take f of x divided by g of x, how do I write it? It gives me what we call the quotient plus a remainder divided by my g of x, which is called the divisor. So this is how we write every division. That is why if we want to express f of x in terms of g of x, we just cross multiply. Okay, so we have f of x to be equal to, we multiply this side of the equation by g of x and this side of the equation by g of x. The g of x obviously is not 0, and when we multiply it with q of x, we get g of x times q of x. Q of x is called our quotient, that is the whole part. Then plus, when we multiply this quantity with g of x, we are just going to be left with what? R of x. Okay, so every division, when I take f of x divided by g of x, I always write it in this form. That is why f of x is equal to this. Now let us take a few examples. Let us begin with numbers. 6 divided by 2 can be written as the whole part plus the remainder divided by the divisor. That is why 6, we can say 6 is equal to 2 times 3 plus 0. 0 is called the remainder, so we can say that 2 is a factor of 6, because when the remainder is 0, it means that the divisor is a factor of the dividend. Okay, now what about, let's take 6 divided by 5. The whole part will give you 1. Okay, will give you 1. The remainder will give you 1. Then we divide it by 5. Now if you multiply all through by 5, we are going to get that 6 is equal to 5 into 1 plus 1. This one here is called the remainder. This one is also called the whole part, which is the quotient, meaning that when you divide what is the whole part and then this is the remainder, and you see that the remainder is different from 0, that's why you can see that 5 is not a factor of 6. Okay, that's the very thing. If my g of x is a factor of my f of x, then my remainder will clearly be 0. So I'm just going to get f of x to be equal to the product of its factors. Okay, we have g of x times q of x. But when the remainder is not 0, then g of x is not a factor. Now let us do some little divisions. If I give you x squared plus 1 divided by x minus 1, we always do long division. Okay, so when we do long division, let me see how I can do long division and you see clearly. Now let us see if there is any shape that defines a long division. Okay, so let me just do it here. So for us to divide, draw our long division sign. Then we have our x squared minus 1, x squared plus 1, x squared plus 1. So x squared plus 1, we are dividing with x minus 1. So x squared plus 1, we put it inside here, and then we divide it with x minus 1, we put it outside. Okay, now we begin with our division by the x squared and the x term. So x squared divided by x is simply x, you see. So that is the first value of the quotient. So we have x, this is our normal long division. Now we take x times x minus 1 will give us x squared minus x. So we have here x squared minus x. Now we subtract. Normally when we subtract, we are going to get x squared minus x squared is 0. So let's draw our subtraction line. So we do x squared minus x squared, it gives us 0. Okay, and then x squared minus x squared is 0, and 1 minus negative x is x plus 1. We are just going to write it in that form. So subtracting, we are going to have, the first thing is that x squared minus x squared is 0. Then we have x plus 1, because 1 minus negative x is x plus 1. So I'm just going to remove this 0 from here. Now I continue my division. Okay, so continuing my division, I'm going to have x divided by x will be plus 1 here, and then 1 times x will give me x, and 1 times negative 1 will give me negative 1. So at the end here, in fact, 1 times x minus 1 is simply x minus 1. I go ahead to divide again. I go ahead to do my subtraction again. When I subtract this, I get x minus x is 0, and then 1 minus negative 1 gives me 2. So x minus x is 0, and then 1 minus negative 1 is 2. So this, we put our x minus 1 there, then we subtract. X minus x is 0, okay, and then 1 minus negative 1 is 2. So 2 is a remainder. Now how do I write this division? So this will be equal to, like we saw previously, the quotient is a whole part, which is x plus 1. So we have x plus 1 plus the remainder. Our remainder here is 2. That is what is remaining, because I cannot further divide, okay, because the degree here is like 2x raised to the power 0, and the degree of x here is less than the degree of x here, so I cannot further divide. So that's where we know that we are going to stop division. So plus my remainder divided my divisor. So if I cross multiply, okay, I'm going to have that x squared plus 1 is equal to x plus 1 times x minus 1 plus 2. If you expand this, you're going to get x squared minus 1, it's the difference of 2 squares, plus 2 becomes x squared plus 1. So we have seen that if we take a polynomial whose degree is 2 and we divide by a polynomial whose degree is 1, the quotient is going to be a polynomial whose degree is 1, and the remainder is going to be a constant. Okay, now because after this we are going to generate something that will help you guys. Now let us just take a polynomial whose degree is 1, and we divide it with a polynomial whose degree is also 1. Okay, let us see what this is going to give us. Now I'm not going to do a long division, but if you do it, you'll see what I'm going to have. So I'm going to make the denominator to be in the numerator. So the numerator is x plus 1. I'm going to write the denominator first, x minus 1. But for me to have x plus 1, I need to add 2 to this. Okay, because when you add up x minus 1 to 2, you're going to get x plus 1. Now I'm going to do x minus 1 over x minus 1, then plus 2 over x minus 1. So this gives me 1 plus 2 over x minus 1. So you see that when I take a polynomial of degree 1 and I divide it with the polynomial of degree 1, the quotient is a constant and the remainder is also a constant. Okay, so how do we now give a general representation? Polynomial of degree 2, the quotient is going to be a linear factor and the remainder is going to be a constant. Polynomial of degree 1, quotient constant, remainder constant. So let's come back to our equation. So in our equation we see that if we take a polynomial of degree 3 and we divide it with a polynomial of degree 2, we are going to get the quotient being a linear factor and the remainder also being a linear factor. Okay, that's what we are going to get, because just try to put maybe x cubed here, x cubed, when we divide the first time and we are dividing with x squared. Okay, for example, let's just take this and see what you are going to get. X cubed on x squared, you see it gives you x. Okay, now x times x squared is x cubed, and then x times negative 1 is negative x. When we subtract, x cubed will cancel and we left with x plus 1 still, you see that we cannot further divide again, so we just end there, because x plus 1, the degree is in x plus 1 the degree is 1, but here the degree is 2, so we cannot further divide. So at the end you see that the quotient is linear and the remainder is also linear. That's just a general case. So I was doing all this explanation so that whenever you find yourself in that situation, you know what to do. So we can say that our p of x is equal to the quotient times our divisor. In this case, what is our divisor? Our divisor is x squared plus x minus 6. And I would like us to identify that if you multiply these two divisors here, we get this divisor. So it's going to help us. So this is our divisor, then plus our remainder. But since my p of x is a polynomial of degree 3 and my divisor is a polynomial of degree 2, then I'm going to let my quotient to be a linear factor. Let's say rx plus s, and my remainder as well is going to be a linear factor. Let's say px plus q, where r and s are constants as well as p and q. Okay, now let us begin with the information. We are told that when p of x leaves a remainder of 12 and negative 8 when divided by x minus 2 and x plus 2. The next question is, how do we find the remainder when a polynomial is divided by a linear factor, for example? How do we get the remainder? The first thing to do is we solve the linear factor equal to 0. We replace that value in the polynomial and the resulting answer gives us the remainder. So let me write the statement. So the remainder when p is divided by x minus, let's say x minus t in general, is simply p of t, meaning we first of all solve x minus t equal to 0. We get the value of x, and x will give you t. You replace it here in p of x, you get the remainder. So it means that when p of x is divided by x minus 2, the remainder is simply p of 2. The remainder is p of 2, and they gave us that remainder as 12. Now p of 2 being equal to 12, what does it mean? Now what is p of 2? You notice that this guy here can be written as x minus 2 times x plus 3. Okay, now if you replace x to be 2, we are going to see that all of this term is going to be 0 because we have 2 minus 2. You're just going to be left with r of x. And what is r of x? Sorry, let's not put p, let's put something else, maybe tx. Okay, now what is r of x? Our r of x is tx plus q. We need to replace so you see that p of 2 will give you q of 2 into 0 plus r of 2. Okay, so 12 will be equal to r of 2. Then what is r of 2? We come here and replace x with 2. We are going to get 2x plus q. Sorry, replacing x with 2, we get 2t. 2t plus q is equal to 12. We can call that the first equation. Now the next information is dividing by x plus 3. So when p of x is divided by x plus 3, the remainder is negative 8. So when it is divided by x plus 3, the remainder is actually p of negative 3, because when you solve p of 3 equal to x plus 3 equal to 0, you get x equal to negative 3. So the remainder is negative 8. Okay, so it means that our negative 8 is equal to r of negative 3, because if you look for p of negative 3, it will be q of negative 3, negative 3 minus 2, negative 3 plus 3, so this will give you 0, and at the end of the day you'll be left with r of negative 3. But what's r of negative 3 is simply negative 3t plus q. So this means that negative 3t plus q is equal to negative 8. We can call this equation 2. We need to solve these two equations simultaneously because the first question is asking us to get the remainder. Okay, so if you take equation 1 minus equation 2, what are you going to get? You're going to get that 2t minus negative 3t will give you negative 5t, and then cure minus cure is 0, and you'll be equal to 12 minus negative 8, which is 20. So 5t equal to positive 5t. 5t equal to 20. We can divide both sides by 5, and we get our t to be equal to 4. Now we can call this maybe equation 3, and then we replace equation 3. So if you fit equation 3 in equation 1, so fitting 3 in 1, what do we get? It means that our 2t plus cure, which is 4, is equal to 12. We can subtract 4 on both sides. We get 2t to be equal to 8. So we divide both sides by 2, and we get our t to be equal to 4 as well. Okay, so our t is cure. In fact, this is t equal to 4, so we need to replace t to be 4 here. Sorry for the error. And then we allow cure here, and we look for cure. So we have 8 cure will be equal to 12 minus 8. 12 minus 8 is 4. Anyways, it's still 4. So cure is equal to 12 minus 8. So it means cure is equal to 4. So it means that our t is 4 and our cure is 4. We are done with that. So our remainder is given by r of x equal to, it was tx plus cure, so it's 4x plus 4. That's what we get. Okay, next part of the equation, given also that x minus 1 is a factor of p of x and p of 0 is equal to negative 2. So first of all, let us write our p of x. Okay, so our p of x will be equal to, our cure x is simply rx plus s. You have rx plus s, you multiply with x squared plus x minus 6. I add it to the remainder, which is 4x plus 4. Now we have information that x minus 1 is a factor. If x minus 1 is a factor, it means that the remainder is 0 actually. Okay, so x minus 1 being a factor, we are going to have that p of 1 is equal to 0. Okay, so let's just go down. Alright, x minus 1 is a factor of p of x. It means p of 1 is equal to 0. Since x minus 1 is a factor. Now, having that in mind, we look for p of 1. P of 1 being equal to 0 implies that, okay, we need to replace x with 1 here. Okay, so we are going to have r plus s times r plus s times 1 squared plus 1 minus 6. Okay, so we have 1 squared plus 1 minus 6. It's going to give us 2 minus 6, which is negative 4. So you can multiply this with negative 4. Then plus 4 into 1 plus 4. We equate this to 0, and then we are going to be left with, this is simply 8. So we have negative 4 into r plus s equal to negative 8. We can divide both sides by 4, and we get r plus s to be equal to 2. We can call this equation star. Now we also have that p of 0 is equal to negative 2. P of 0 being equal to negative 2. What does it mean? It means that we replace x with 0, we are going to be left with s into here is 0 squared plus 0, so you have minus 6 there, so minus 6s then plus 4 equal to negative 2. So from here directly we can get the value of s. So minus 6s will give you minus 6, so it means that our s is equal to 1 because we divide both sides by minus 6. Now we can call this equation star star. Now we fit equation star star in equation star. What are we going to get? We are going to get that our r first of all is equal to 2 minus s, which is 2 minus 1, which is 1. So our quotient is it was rs plus s, right? So our r is 1 and our s is 1 as well, so then we get x plus 1. So q of x equal to x plus 1. Okay, now next part of the equation, express p of x as this. So after expressing it, we are going to verify if actually x minus 1 is a factor. Okay, and then you're going to see the controversy that I'm talking about. So p of x is equal to the quotient x plus 1 times our dividend x squared plus x minus 6 plus the remainder, which is 4x plus 4. If we multiply the first, okay, we are going to get x cubed plus x squared minus 6x plus x squared plus x minus 6, then plus 4x plus 4. Now x squared plus x squared is just 2x squared. Okay, negative 6x plus x is negative 5x, then minus 6. Now negative 5x plus 4x is simply negative x, then negative 6 plus 4 is negative 2, so we have negative 2. So at the end of the day, this is our expressing it in a form ax cubed plus bx squared plus cx plus d. We have that, so we can just indicate the values of those constants a, b, c and z. So we see that our a is a coefficient of x cubed, which is 1. Our b is the coefficient of x squared, which is 2. Our c is the coefficient of x, which is negative 1, and our d is the coefficient of the constant term, which is negative 2. Now let us verify if actually x minus 1 is a factor. Okay, now if x minus 1 is a factor, it means that, like we said, p of 1 should give you 0. But what is p of 1? Our p of 1 is equal to, we replace 1 here, we get 1 cubed plus 2 into 1 squared minus 1 minus 2. Okay, anyways, it's okay. P of 1 is 0, so we are okay. 1 plus 2 is 3, then minus 3. Okay, I understand is 0, so we are okay. The controversy. Okay, now let us see if p of 0 is negative 2. P of 0, we just have everything here 0, we get negative 2, so we are okay. Let us see if where is it, if those are our divisions. If p of 2 is 12, p of 2 is what? Yes, 8 plus 8, 16, minus 2, 14, minus 2, 12. Okay, and lastly, p of negative 3 should give you negative 8. Here you have negative 27 plus 18, that's negative 9, plus negative 3, that is negative 6, minus 2, negative 8. So we have completed the problem.